was a sight from my soul.
Morning, guys. Larry, Dynomite Diesel Products, and I'm here with Skylar Ostrich, the guy that builds a lot of your guys' really big hot rod injectors. And today, I want to talk to Skylar about something on the other end of hot rod, and that is the blue truck.
Yes. So recently, we went out and bought a bone stock blue 05 truck, basically just to do some testing on it. We needed to test some more things, so Lenny went out and picked up one of those. We ripped the injectors out. We wanted to try some new not extrude home, AFM technology with some nozzles and stuff, and we wanted to actually drive it ourselves and to see how they performed, and obviously dyno it. So I am been driving that for about the past week, putting a whole bunch of miles on that, and it's a night and day difference from extrude hound to AFM technology on the way the holes come out to be shaped and everything.
So I do want to reach out to Pat from Australia for helping us out, because we test all these things, we learn some stuff, but we're not being formally educated, and we don't really know the proper terms or verbiage to describe what it is we're learning and testing. So doing it our way, it's pretty much like hammer, rock, nails. We figure it out, we make some numbers, we put it on a dyno, we drive them, we get it to run good. But having Pat overwhelm me with stuff that he reads, and super sharp guy like him, and I met 4 dudes from Australia when I was in Texas, the show, and wow, overwhelming. But then he really piles it on with all this stuff. And there's things from U.S. Patent Office here. There's things from colleges in Japan. There's things from OEMs. There's things from everywhere. But basically, the visualization that's going to be, speaking of technology, this green screen stuff, super cool. So we're going to show you a picture of EDM holes right now. And now that one's gone, we're going to show you a picture of extrude honed holes right now. And right now, we're going to show you what an AFM hole looks like right now. And hopefully we can put all 3 of those back behind us so you can see side by side what the different hole looks like on the inside after the different processing. Now, I really enjoy, because those are a 90 horsepower injector in that 325 truck you're driving. Yep. We put a new fuel filter in it. It's basically a truck that Dave Smith Motors traded in. They couldn't sell it because it barely ran. Fortunately, there's a can of ether in it when I went to the car lot and picked it up. So I started it a couple times, drove it home, and we put a set of injectors in it. It's got aftermarket control valves that we've testing. Yep. We've got at least, 3 or 4 or 5 sets of those in-house testing right now.
Correct. Between all those trucks,
all the employees, trucks, customers. Yep. Yeah. So we've got a bunch of control valves we're testing right now that are aftermarket, and they're working out really good. Machining looks awesome. The hardened seat looks great. Everything about the control valve is really checking out very, very, very well. And with some of the other control valves that we've tested in the aftermarket, like even rate shape is wrong.
Yeah, so the response time of an injector, it's really critical, like not just on big stuff, but it's critical on little stuff too. Like you want that injector to start, and you want that injector to turn off at the exact same time. That's how you're going to get the smoothest running motor out there, is basically watching rate shape. And if you got, let's say you got an injector that's just say 20 US delayed compared to a different one, like your average person's probably not going to realize that.
And the test stands, most test stands won't see that.
Most test stands won't even see that.
It's going to measure the cube, and it's going to see it correctly, but it's not going to see when the fuel turns on and when the fuel turns off. And green screen technology, go ahead and, Tyler, put that up there right now. So this little dyno graph looking thing right here is actually what Skylar gets to look at every single day. And his test stand finds stuff because of rate shape instantly when the others can't find it at all.
Yep. Exactly. So it's just really critical on having an injector that's firing and shutting off at the exact same time. It's not only with not only with a balanced injector, but basically when I'm building stuff, I'm actually kind of taking another step, watching rate shape. And if it looks great on something that we're testing and we feel comfortable, then we'll have other guys build it that don't have the rate shape stand, because we know it's going to function and work properly the way it needs to.
Yeah. So I think what we're trying to say is when we design a recipe using that test stand, that recipe can be carried to the other test stands, but setting up the shim stack and getting things to where they function at the correct time with correct measurements and all those things, that stuff, when you get the recipe like dialed in, all the rest of the test stands will run it and they won't have problems with delays. But since COVID's hit, we've went to aftermarket manufacturers to try to get nozzles made. And due to the fact that we couldn't get nozzles from the OEMs, we were just out of parts. We have our own EDM. We've got our own AFM. We've got our own extrude hones too. So with all that stuff in-house, we just asked to have blanks made. And some of the blanks for well over a year, absolutely perfect. And then we started getting into shipping problems because COVID, nobody wanted to work. And then the people that did work had to work their butts off. And then we got into issues where the nozzles themselves were giving us fits.
Yep.
So we were spending hours and hours and hours to try and get stuff shippable. And then we got back a lot of stuff under warranty. I shouldn't say a lot, but we got back way more than normal.
Way more than we wanted to, yeah.
So we're shipping out parts. Our shops are like frustrated because the parts aren't lasting as long as they used to. And that drives us to meeting our friend Randy.
Yep.
Randy is, he worked for an OEM, a very large OEM, and manufactured about 12,000 nozzles per day at the high time of his career with they would test for 10,000 hours, which is 450,000 miles because national average is 45 miles an hour, 10,000, 450,000 miles is what they would test parts before they release them. So with his expertise and all the people he knows on the planet, he's giving us the tools. He's now a Dynomite Diesel consultant and is an employee of ours and is helping us meet new people with new tools. So we have picked up measuring devices. So we can actually measure the straightness and the trueness of the needle valves. We can measure all the angles and the seat, the surface finish of the seat. We can reach down inside the nozzle, measure the seat, measure the trueness of the bore, the guide bore where the needle valve drops in. And with all of that stuff, we now have specs and blueprints so we can measure parts, check that stuff out, and who knows, someday in the future, maybe even make our own parts right here in Idaho. So these tools, they're helping us out quite a bit. They're not cheap, but it's really truthfully the only way that we can kind of combat Build Back Better.
Yeah.
Yeah, Build Back Better has been expensive and not very good so far, but we're spending a lot of money on tools, new rate shape stand. We got another stand sitting out there in a crate right now. Our building needs more electricity. We've got construction going on in the building.
Yeah.
It's been crazy. We've sold 2 stands this year, and both those are out there. We got one over in Seattle, Diesel Dudes.
Yep.
Well, then we got one up in Armor. So those guys are able to help, kind of keep the load of injector testing off of us. But I've been studying this little packet right here, and I've read this half a dozen times. And my favorite part is the back page because it's got a bunch of dudes' pictures, and I understand them. So it's a college-written education format by a bunch of Japanese fellas, and they were studying extrude hone, basically hydro grinding or abrasive flow machining or extrude honing. They studied it all in a big packet, and what they've come up with is a couple of terms that I really like: vortex flow versus cavitation behavior inside of a diesel nozzle. Really simply put, a great big hole with no K factor, no chamfer leading into that spray orifice is going to give you a cavitation style spray pattern. So when the fuel breaks through a 90-degree edge, blink. I love this green screen thing. It's cool. When it breaks over that, you create a low spot, a low pressure system all the way around that spray orifice. So if the hole is, say, 20 thousandths of 1 inch, you're only actually feeding that with maybe 15 or 10 thousandths. And as pressure goes up, the low pressure area increases in diameter as well. When you create the K factor, blink, that K factor, we study Austin.
Yes.
Every single recipe.
Yeah.
We LB7s the other morning. Yep. We spent how many hours to build the first injector?
I mean, we spent all morning doing it. So 4. I mean, I worked on it day before. So yeah, we at least got 4-6 hours in studying nozzles.
I worked on those nozzles on Friday. You and I worked on that all morning long. So 2 dudes that know kind of a lot.
Yep.
And we worked on it for 4 hours before we were ready to ship the first one.
Yep. To actually.
And the other 7 are easy. It's the first one. So our body wasn't big enough, and they didn't pump anything. We had 84 liter a minute extrude hone nozzles with big wire. Then you said, nope, that's too big for that body. We put it down to a, you remember what wire that was? 11.2?
I thought I don't remember the wire size. I felt like we dropped like 1,000 or something.
I think it was like 3,000 at first, and then we kept bumping it up. Anyways, so we kept on. Extrude honing versus AFMing is a very different process. It's not the same at all. They don't react the same. Extrude hone has its, is still the champion in some hole diameters at some pressures. But AFM, like in street-driven trucks, AFM kicks the ever-loving bejesus out of extrude hone on the street. Hands down, every single day, all day long, it works the best. When you get to the bigger, like sled puller, drag racer stuff, sometimes still extrude hone is the champ, but not every time. So when we're building these custom injectors, we have to do a lot of testing.
Right, we're still doing testing on them.
Did we make 5 nozzles, and each one of those nozzles we AFM'd 3 times?
We either made 5 or 6. It was quite a bit different ones.
So we tested 3 times 5. That's 15 different size nozzles, basically, in one morning. And then come to find out, the extrude hone that I made on Friday ended up being the champ on that body.
Yes.
But we also found out that there is a certain size on an LB7 where the edge filter has to come out to really get optimum fuel flow out of the injector body.
Yeah, you can definitely benefit from that. Yep.
Is it great to knock out edge filters? No. Why? Because when the fluid gets pushed past the edge filter, all of the stuff, all the really small stuff that's in the diesel fuel hits the edge filter, shatters into really small particles, and it's small enough now that it'll pass through the injector without hanging the injector. Remove the edge filter and headaches. So it's not good. You don't really want to be the guy that isn't running edge filters unless you're the guy that's going to get perfectly clean diesel, strain the diesel when it goes in the vehicle, and make sure that you're on top of the fuel filter situation in the race car or in the sled pull truck all the time, because hanging a control valve open causes a massive overfueling issue, big misfires, all sorts of things. The clearance between the needle valve, where it seats, and the nozzle valve is 2 micron. A micron is like a decimal point, 6 zeros over 47. So about 47 millionths of 1 inch is a micron, and you're allowed 2 micron interference between the needle valve and the nozzle. So yeah, you're not going to catch all that. It's millionths of an inch. You may have a 2 micron filter in there, but it's not going to stop every little thing. When we look inside your nozzles, we often see things inside diameter of the average hole is about 8 thousandths. And we see stuff in there that's much larger than that oftentimes. So even though you guys are running a 5 micron filter, 10 micron filter, 7 micron filter, I don't care what the micron is. It's not catching every single thing, period. Have a nice day. And you're going to contaminate injectors. So edge filters are there to protect you and help your injectors stay alive a little bit longer. That's why we like promoting people just staying with them and using them. But if you're going to be the 1,1600 horsepower PPL guy on limited air, or the 2,000 horsepower plus guy that is trying to make big power, you're only going to whip up 2, maybe 3 gallons of fuel at a time. Take extra caution when you're using that stuff and make sure that you keep it perfectly clean. Don't store it in the truck. Like, just all the things you can do to prevent any sort of future maintenance problems. If you're removing the edge filters, it works, but be dang sure you protect yourself.
Yes.
Now, with K factor, there's this study from Chalmers, lots of packet, lots of words, lots of things, lots of equations on what the radius needs to look like. Gases, like NOx gas, for example, by using the same liter per minute nozzle on the AFM, by changing wire diameter. Say if we go to a 10 thou piece of wire and we run it on the flow meter to, say it's a 6x10 and it flows 60 liters per minute, put in the stand, does it pump?
I mean, it pumps, but not that great.
Not great.
No.
We run it for 5 seconds on the AFM. We pick up usually
anywhere from 50 to 100 MMs.
So it could be 10 to maybe 25% in the first 5 seconds on the AFM. The second 5 second hit could also, if the first 5 second hit didn't give you enough K factor, The second 5-second hit gives you enough K factor.
Yep.
And then you pick up possibly 5 to, well, it should be in 20 to maybe another 100 mm.
Yeah.
Yeah. On the same diameter hole. So when we're talking about hole diameter and using that as a barometer to figure out how much power you're going to make, it's a really bad way to do it. The only thing that makes horsepower is going to be burnt fuel, not smoke out the stack. The fuel you burnt that shoved the piston down is the only thing that makes horsepower. So K factor is critical. And when we're doing what we're doing and how we're testing it, we got the P-pump stand in a few months. That'll be set up. And then we're going to start testing mechanical injectors on P-pumps and figuring out what the K factor absolute and perfect needs to be on that stuff, because we can clear up smoke, we can clear up exhaust gas temperature issues, and we can help you decide if you've got a 250cc pump or a 400cc pump, 1000cc pump, which injector is going to be optimum. Yep. We're the only people in the industry currently that even bother making the holes and then looking to make sure we have enough K factor. But without running them the way I just explained, we're kind of guessing as well.
Yeah.
Because using AFM, you're looking at something, you might create another half thou of radius or that K factor, and all of a sudden, boom, you found this sweet spot.
Yeah.
Don't smoke. Okay. In a street-driven truck, the 90 horsepower injectors that are in this, how many miles are on that truck? 238, I think? 240, almost 240,000 miles. Worn out motor, kind of ish, like it runs, but it's not a spring chicken.
No, not a fresh motor.
90 horse injectors on a extrude hone nozzle from 10 years ago. Every single one of them would have had tip-in rattle. Yep. Would have had a little bit of smoke down below the turbo, and then it takes off and runs pretty good. Yeah. You put it on the dyno, and it makes 90 horsepower, maybe 100 horsepower. Everybody is happy about it because that was the technology we had.
Yes.
Today, you drive this 240,000 mile truck. What's it run like? What's it start like in the morning cold?
It's like any other truck, like early 3rd gen truck I've driven. It fires, so you basically touch the key and it fires up. The drivability, I've been trying to make it rattle. I can't make the thing rattle. And then smoke like rolling into it. Like I've driven it like a white man, and I've driven it like I've stolen it, and I can't make it smoke. So
that thing's amazing.
Yeah, it's amazing.
Yeah, and it gets really good fuel economy too.
Yes. Yep.
What I like about how we set our idles, our LL delivery is really high compared to where everybody else would think it would be
higher in spec for sure. Yeah.
But when you're in the parking lot and you go to turn the steering wheel, the tachometer on our stuff stays stable and solid. Mm-hmm. You go to flip the air conditioning on or the defroster on, that could be a 15, 20 horsepower hit just instantly. And usually the tachometer in the truck will flicker just a little bit. Our stuff doesn't do that. You start our stuff cold, there's enough fuel there that it generates enough heat that our stuff doesn't do the white idle haze stuff. Yep. So you might see maybe 2 to 3 seconds. If it's like 10 or 15 degrees outside, you start the key, let the heat grid cycle for like, I'm very impatient. So I'm like more of a 10-second, like tops guy. Like if I don't just get in and start it, I might wait 10 seconds. It'll smoke white for maybe 2 or 3 engine revolutions. Yeah. Then it clears up and smooth. Yep. So very, very nice stuff to drive, but we're doing things differently. We're always, like Skylar says, we just run out and buy a truck because, well, everybody else has got a truck that's that old with that many miles on it. We got to figure out what they're up against. So thank you again, Pat, for all this paperwork. It'll take me years. Literally, it will take me years to learn 25% of this stuff. Yeah, this is overwhelming, but you are a stud, and I really do appreciate it because there is so much information here that we don't know, but we test. Now we can start putting proper verbs and adjectives to it and sound more intelligent, I guess. Yeah. It'll sound that way. I'm not going to be any smarter, but it'll sound cooler. And, you know, like for you guys out there that are looking for parts right away, what's our average wait time on a set of injectors right now?
Like your basic Ecos 50s, 90s, we have them on the shelf ready to go. So if you call early enough in the day, those will ship same day. 120s will, like 120s to like a 300 horse injector will either ship, depending on when you order. If you order them early enough in the morning, those things will ship same day too. If not, either another day or two. So everything basically we build is, I'm going to say on the safe side, 1 to 4 days to be able to ship out.
And that's the like 0 to 600 horsepower stuff.
Yeah, like well, I mean, we even have we have 150% overs on the shelf. 3 hour stuff for you 12-hour horsepower people. We have those ready to go. So like we have a lot of product ready to go right now. We're just trying to keep up with everything, keep testing, and keep you guys happy.
Inventory has grown since COVID started by about 400% because people that can't get things when they call here, their patience has run out and they just want something. So we have answered that. An apple cart is only an apple cart if it's full of apples. Otherwise, just an empty cart. So we've tried to be the apple cart with apples on it. And there has been some struggles and some pains and some frustrations, but we've still maintained the full apple cart and we're still there today. Now on the 3 and 4 and 500 horsepower stuff, we have basically run out of some of the nozzles. And because of that, some of those things are going to be delayed by months. But we've also been studying other options and trying to get the same millimeters cubed delivery, which has forced us to do some things differently than we used to do. And even though I know for a fact that our stuff is on and off faster than anybody else on the planet, we're now even faster.
Yes.
So with the testing that we've got going right now, how many microseconds quicker are we at end of injection?
You talking about just like some basic stuff? Or?
No, like the 400% stuff.
I'd say we're probably at least 200 microseconds quicker than anything else I've ever seen out there, ran, and tested. So
that's a big deal.
Yes.
You can't see that in every single stand, but you can see it on a Skylar stand. And because of that, we're just changing shim stacks, believe it or not, even needle valve geometry makes a big difference in what the response time of the injector is going to be. The weight of the needle valve is going to change the quickness in which it opens and closes.
Yes.
These are things that nobody else on the planet's even thinking about. We are thinking about it because we're thinking about the future. And I promise, like, you can't get higher technology injectors from anybody else on the planet right now, period. Because, well, basically it's just Skylar, because I'm really never here. But trying to run this place a lot. Trying to learn, when you go to some place at Mar or Zeiss and look at these fancy space age tools, I got to jump on an airplane. Oh yeah, P.S. by the way, thanks Alaska Airlines for losing my bag. It was mint. I loved it. I don't have much of a neck. You guys know this. And I have to use this like sleep device to kind of pull my jaw forward so I sleep decent. Well, they lost my bag, so I didn't sleep for like 4 days basically. And they were like, oh, no problem. Fill out this paper and we're going to reimburse you. Well, that sleep device is $2,000. And it's like 2 months to order a new one. So fortunately, it showed up like a week later. Well, it was like 4 or 5 days after I got home. So thanks for giving me my stuff. But yeah, the bag looks like it flew across the United States, hanging out the back of the airplane. And it wasn't that bad. It was that bad. But we've been doing a lot of traveling to try and make sure that we're getting cool tools. And even with the AFM, that was frustrating for like 12 months.
I mean, it still is frustration up to today sometimes, depending on what we're doing.
Yeah, it's frustrating because you know it can work, but you don't have the recipe dialed in until you have the recipe dialed in.
Yep. So
it is frustrating because, 10, 15 years ago, we're just shoving media through there and make it bigger. Okay, make it bigger, make it bigger, make it bigger. You pulled the nozzles off of Chuckle's Garage stuff yesterday.
Yep.
And those were just some Bosch P2200s that we basically over extrude honed to get the quantity out of them years ago.
Yes, a long time ago.
And today we look at that and we'd be ashamed that we ever did that.
Yes, that's basically what I said. I was like, wow, we're going to redo this.
Yeah, everything gets redone. Like all of his stuff gets redone.
Yeah.
That thing's the current world record holder for diesel-powered vehicles going up Pikes Peak. So with some new technology in it, it's going to be even cleaner, more powerful. Super excited about that. But if we don't keep investing into tools, we're not going to, it's not just that you're cool. It's the fact that you have really good tools.
Yeah.
And it's the fact that I really like really cool tools. So I'll never have money, but I'm always going to have tools. That checks out. Skylar, anything else you got?
I think we kind of hit on the basics, what we're working on right now, and just kind of give you guys an update, and I think we're good.
Well, that's about all I got. And again, thanks Randy and thanks Pat for helping us out and keeping us growing, and that's a lot of stuff. Appreciate you guys. Thanks, Lenny Reed, Dynomite Diesel.
Skylar Ostrich, Dynomite Diesel.
There goes a sight, there goes a sight. Now there goes a sight from my soul. cause a sight from my soul.